You were teaching me about meal prepping and how to visualize how much calories are in like a food item. I mean, you did some homework. Can you tell me what you found?
So, yeah, I did some conversions for different food items into joules, which was not what I expected.
Okay.
But first, we should go over what is a calorie because it's super confusing.
Okay.
Because let's go to the Wikipedia
Wikipedia.
page.
Okay. Okay.
And calorie, we read it here. The calorie is a unit of energy that originated from the caloric theory of heat, which I don't think exists anymore. The large calorie, food calorie, dietary calorie, or kilogram calorie
What?
is defined as the amount of heat needed to raise the temperature of 1 liter of water by 1 degree Celsius or 1 Kelvin. The small calorie or gram calorie is defined as the amount of heat needed to cause the same increase in 1 milliliter of water. So annoying.
Okay, but I guess that's the
It's
same because they go from 1 liter to 1 milliliter, and then here, oh yeah, here it is.
yeah,
Thus,
yeah.
one
One
large calorie
large
is equal to 1,000 small calories.
So
Why?
first off, we shouldn't even be using the calorie because it's annoying. We should be using joules.
Yeah,
Just 'cause- why
standardize
not?
it with the rest of SI.
Right. And if you look over there on the side there, it says 1 calorie is equal to 4.184 joules. Thanks, science.
Thanks. Yeah. Why use this
And
thing?
it gets worse because the large calorie is capital C calorie, and the small calorie is lowercase c calorie. Ugh, so annoying.
It's the same word.
It's the same word,
Garbage unit.
and one is capitalized, one is lowercase. That is not what we do in anything else. We'd have prefixes to other things.
Oh yeah, imagine like the gallon and then the gallon. It's the same
Right.
thing but 1,000 times bigger. You just say it louder.
It's,
I guess-
yeah, like what the heck?
There's also here this
And then, like,
kilocalorie. But
Right,
kilocalorie
kilocalorie.
is a calorie, but not the little calorie.
it's-
Not the
it's-
calorie.
Actually, yeah, why don't we just call it a kilocalorie?
Why don't we just call it a kilocalorie?
Just drop the capital C calorie crap.
That's right.
Just call it a kilocalorie. Done.
Kilocalorie.
In fact, why don't we just drop the calorie altogether and just deal with joules? It's not like a calorie is that far off of a joule anyway.
That's right.
Just a 4 times larger.
Let's just use this. I mean,
Yeah,
what?
let's
Okay,
use that.
what would practically change? What would practically change is all of our food labels would change by a factor of 4, and then we'd be able to convert this energy into whatever else you needed to.
Right. But right, those food labels are created and you get used to seeing your numbers in calories. So switching to joules would be a pain because you'd have to fix your brain as you look at the food label. But if we had started in joules, everything would be fine. The numbers would look normal. So now that we're stuck with calories, ugh,
We're stuck with it.
so annoying.
All right, but then okay. Stick with the big calories, big capital C or kilocalories, however you want to call it. But then, how do I
Yeah.
visualize what this means in terms of like meal prepping or whatever?
I see. Okay, well, first the question is, for food,
Uh-huh.
when you look at the label, is it a kilocalorie or a calorie?
I think it's a big C calorie.
So it's a kilocalorie.
Where is this? Big C calorie.
right.
Kilocalorie.
But everything else is capitalized.
Oh shit.
Like niacin is capitalized.
That's right. Oh, this is big niacin.
It's big niacin. That's a kilogram of niacin. Like, ah. Okay, so we think it's kilocalories.
Yep. Yep.
Pretty sure.
I think so. Yeah.
Okay, so let's check the first one. We did what did we do first? Hamburger? No,
Taco?
crunchy
Taco?
taco from Taco Bell is 179 kilocalories, which is 711,000 joules.
Multiply by 4, multiply by 1,000. This thing. Okay, so it's like
Multiply by-
an annoyingly large number, but I guess you get used to it. Or you call it 711 k joules.
KJ. Yeah.
KJ. Hey, KJ.
Okay, so what's next? Let's look at a hamburger.
A big
Yeah,
Mac.
Big Mac. Here we go.
Oh yeah.
Yeah, so we got 508 kilocalories is 2.4 million joules. Nice.
Okay.
Okay.
Sure.
And then next one, cheeseburger with onions, 430 calories. That's 1.8 millijoules. That's million joules or what is it?
No, megajoules.
Megajoules. Megajoules.
Yeah, big M. Okay. Okay, so that's
Okay,
what
yeah.
these are. I just memorized it, I guess. But I still don't.
Yes.
So if I like look at this specific cheeseburger with onion, then I can understand that that's 430 big calories. But maybe is there like a different way to visualize that so I can like see what does that look like in the real world?
So I compared that to a baseball falling 10 feet. So drop a baseball 10 feet, and the energy starts out as gravitational potential energy, and then once it hits the ground, that potential energy is converted to kinetic energy.
Yep.
How much energy was transferred from potential to kinetic? So did the calculation. So the potential energy at the top before we drop it is mass times g times the height above the ground. And then so I plugged in the mass of a baseball, 0.145 kilograms times acceleration of gravity times 10 feet.
Sure.
Okay. And then converted 10 feet to meters,
Yep.
which is 3 meters-ish. And then
Crank that
I
number.
wrote it again.
Yeah,
for no
write it
reason.
twice. Yeah, just make sure.
Yeah,
Make sure you get it
verified.
right. Yeah,
There
okay,
we
very
go.
good.
And that's 4.3 joules. So,
that's almost
holy
like a
crap.
calorie.
So that is not a lot of energy.
That is,
So if you want
gosh.
1
okay.
calorie, we got to get to 10,000 feet. Is that what you wrote there?
Yeah. Yeah, right? Wait, what? Okay. So this is one little c, right?
Yeah.
That's what we said
Yeah.
here? What it's this many joules is one little c?
Yep.
So
Yep.
then if we want to get to big capital, it's a factor of 1,000,
Yep.
which makes this
10K feet.
1,000.
Yeah.
No.
No. That was
Oh,
right.
no,
That's
10
right.
feet, 10 feet. That's right. Okay, you're getting
That's
it.
right. That's right. Three
Wow,
zeros. Yeah,
10,000
yeah.
feet. Okay, how high how high do airplanes fly?
They are, what, 30,000 feet?
So we're saying if we drop, wait, so this is 1 calorie, 10,000 feet.
Yeah.
So if you drop a baseball from an airplane, that's less energy than what's contained inside of a hamburger or cheeseburger with onion.
It's far less energy.
Holy cow.
Because if you're at 30,000 feet and you have a baseball in your hand and you drop it out of the airplane, then the potential energy relative to the ground for the baseball is 3 calories. Like, holy cow.
430 divided by 3 calories is 130 something, 130 something.
Something.
Yeah. So you got to throw a baseball up 130 times to hit an airplane. That equals the energy you would have gotten from a cheeseburger.
From just a regular cheeseburger. Nothing special,
What?
just a cheeseburger.
What? This is
What?
so much energy in our food.
So much energy. It's crazy. It's wild. So that means the Big Mac with its, wow.
580 calories. Wait,
You
does
could
that
launch
mean
a baseball into orbit, could you?
Sorry, if you could okay, this is like Star Trek meta energy converter. If you can decompose a Big Mac into just pure energy, you like launch stuff into space with Big Mac power.
Yeah, but I guess what this calories though is only the bioavailable energy in the chemical bonds.
That's
Big Mac.
good point because what they're
Because if you were to convert an entire Big Mac to energy like E equals MC squared, that's like
much more.
would wreck the Earth.
That's yeah. That's right, because this is the way I think this is like, if I remember from chemistry, it's something about burning a donut. And you burn a donut, and then you can look at the flame, you can figure out the energy rate, and then you multiply up by the mass. But that burning from that flame is just the chemical bonds. You're not like ripping atoms apart. You're not doing fission
That's right.
reactions.
Yeah. And I guess it's only breaking and reforming bonds for certain weaker bonds in the
That's right.
in the food. Most of the bonds, I think, just stay put. Right? They can't break.
Right.
So it's actually a subset of the bonds that break. So, holy cow!
Incredible the amount of energy that's inside of a hamburger.
Yeah.
I think
Crazy.
either you did it or I did it. We got some more of these.
Okay. What's
So
this?
I got okay.
Okay.
So I said, okay, what is this in terms of like gun stuff? So if you a 9mm bullet's muzzle energy typically ranges from 480 to 730 joules. We saw a joule is kind of not a lot here, right? So then I said
little bitch energy. Yeah.
little bitch energy. So for like a typical 9mm is like like the energy when it leaves the barrel is like 494 joules. So I converted this 481 joules. I took this number there, I guess. This is 0.01 calories. So if you were to shoot like 900 bullets, like 9mm bullets, that's a cheeseburger. There's so much energy in our food. We're just like chomp chomp chomp. I'll eat 3 of these. Chomp 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 chomp.
So much energy.
Can you eat 2,700 bullets? That's 3 cheeseburgers.
Okay, I guess that kind of makes sense though, because a bullet has concentrated energy in this little thing.
That's a good point.
So you just put a little bit of energy. It's got this like piercing power.
That's right.
If you put that much energy in a big object, it's just not going to move much.
Do we have one for big objects?